In this video we will look at the phases of MapReduce. The two major phases are map and reduce, but we will see that there are two other minor phases. Here we see listed the four phases: map, shuffle, reduce and combiner. The combiner phase is optional and fits just before the shuffle phase, but we will look at the four in the listed order for your better understanding. This slide provides an overview of the complete MapReduce version 1 process. File blocks stored on different data nodes in HDFS are read and processed by map tasks running on the data nodes where the blocks of data are stored. The output of the map tasks are shuffled, then sent to the reducer tasks, one output file from each mapper task to each of the reducer tasks. The files exchanged here are not replicated and are temporarily stored local to the mapper node. The reducers produce the output, and that output is stored in HDFS, one file for each reducer, and it's replicated. On a previous slide we saw something to the effect that if you write your program in a special way, the programs can be brought to the data. This special way is called MapReduce and involves breaking the program down into two discrete parts, map and reduce. Let's look at the map phase first. A mapper is typically a relatively small program with a simple task. It's responsible for reading a portion of the input file data, one block of one file, interpreting, filtering or transforming the data as necessary, and then finally producing a stream of key value pairs. What these keys and values are doesn't really matter for this discussion, but just keep in mind that these key value pairs do not have to be simple values. They can be as large and as complex as you need for the job at hand. As shown in the diagram, the MapReduce environment automatically takes care of your small map program, the blue boxes on your left, and pushes that program out to every machine that has a block of the file that you'll be processing. This means that the bigger the file, the bigger the cluster, more mappers will get involved in the processing the data. And that's a pretty powerful idea. The next phase is called shuffle and is orchestrated behind the scenes by the underlying MapReduce logic embedded in Hadoop. The idea here is that all of the data that is being emitted by the mappers is first locally grouped by the key that your program chose, and then for each unique key a node is chosen to process all of the values from all the mappers for that key. For example, let's say you use US states, Massachusetts, Arkansas, New York, California, etc. as the key for your data. Then one machine will be chosen to send all of the California data to, one for all of the New York data, and so on. Each machine would be responsible for processing the data for its selected state or states. In the picture above, Hadoop has decided that only two sets of keys, yellow and purple, are needed. But keep in mind that there may be many records with the same key or set of keys coming from a given mapper. Reducers are the last major part of the picture. Again, reducers are small programs, well, typically small, that are responsible for sorting and or in particular aggregating or reducing over the values associated with the key or keys assigned to the reducer node. Just like with the mappers, when a larger number of reducers are used, the more parallelism that can be provided. Once each reducer has completed whatever it's assigned to do, maybe for example add up the total sales for the state or states it was assigned, it in turn emits key value pairs that are written to HDFS disk and in turn be used as the input to perhaps another MapReduce job. In an extremely oversimplified nutshell, that is MapReduce. At the same time as the sort is done during the shuffle work on the Mapper node, an optional combiner function may be applied. For each key set, all key values with that key set will be sent to the same reducer node. That's the purpose of the shuffle phase. Rather than sending multiple key value pairs with the same key value to the reducer node, the values are combined into one key value pair. This is only possible where the reduce function is additive, that is, doesn't lose information when combined. Since only one key value pair is sent, the file transferred from mapper node to reducer node is smaller and network traffic is minimized. This is the end of this video. In the next video we will look at an example program, word count.